my screen then. Can everyone see that all right?
Yes.
Yeah. All right. Hi, everyone. I'm Andy. I'm here with Farad.ai. Going to talk a little bit about the work that we've been doing in the MEDApps competition, who we are, why we're doing it, the problems that we're aiming to solve in the industry. I'm going to talk a little bit first about who we are, and then going to talk about the problem that we're trying to solve, and then what we know about the solution. And by we, I don't just mean us, I mean the UK through this MEDApps competition, and also our developments as Farad.ai in demand prediction at the low voltage end of the electricity network, and our developments in network modeling. So first of all, who are we? We are Farad.ai. We're a relatively young startup that was set up really on the idea that the power sector, if we're going to achieve net zero, needs to change on quite a fundamental level. We want to try to address the risks that are involved in this decarbonisation transition, mitigate the effects of climate change, minimise the costs to consumers and businesses by effectively finding pain points in the industry that are preventing decarbonisation from happening. So what do we see as the problem? Really, it's that the power sector doesn't have a clear vision at the moment for how it's going to decarbonise. We know that the current way of doing things isn't sustainable. We know that the way that the power sector operates at the moment, with gas turbines at the top level of the network, the transmission network, feeding down to the low voltage end, reacting kind of in real time to increases in demand just by spinning the turbines up. We know that that's not going to work when we transition over to wind and we transition over to solar. What we don't really know a lot about is how that new technology interacts with our electricity network. So renewables are being connected at all voltage levels of the grid, not just the transmission network. Solar panels are being put on people's roofs, utility scale renewables are being plugged into the distribution network, and how those technologies interact with the grid isn't particularly well understood, but also the complex power flows that are being created inside the network by connecting supply and demand at all these different voltage levels are not understood. The grid is sort of going from a top-down, one-directional grid to a bi-directional one, and those complex power flows aren't very well understood, and worse, are poorly monitored. And that's really why this MEDApps competition exists, or one of the reasons why this MEDApps competition exists, is to modernise energy data access and applications. And we know that demand in the next 30 or so years is going to increase by 100%. So this is a really important problem for us to solve. It was in 2020, Bayes published a white paper saying that demand is going to increase by 100% by 2050. At the moment, gas makes up around 40% of our electricity, which means that if you connect the dots there, renewable energy needs a fourfold increase to meet demand. Or to put it another way, the growth in our renewable energy capacity as a country needs to outperform the FTSE 100 for the rest of my working life. And that's a big, big challenge. So how are we going to do this? I think one of the problems in the energy sector that we see is waste. So 54% of our electricity is wasted before it gets to households. Now, a lot of that is in the resistance in electrical wires. There's nothing we can do about that. That's just an unfortunate reality. But a lot of it also comes from the inefficient management of our network assets and the lack of visibility and the lack of data in the power sector. And this is going to be an even bigger problem when we lose the ability to control when our generators are running, when we're reliant on wind blowing and sun shining. And this means that digitalization really is an urgent requirement for the UK and for the world if we're going to address this waste. In other words, if you want to put it in the way that the current government would put it, the power sector needs to level up. And that really is what we are working on at Farad.ai. The big picture of what we're working on is laying that foundation for the levelling up of the power network for a net zero future. Now, we don't know what that power sector is going to look like in a post-carbon world. Truth be told, nobody does at the moment. We're in a very lucky position that the UK government has done a huge amount of work on data openness. They've assigned this budget for innovation in the power sector to help small and medium enterprises like ours figure out what the future is going to look like. And it means that in the UK, we are in quite a unique position where we know a lot more than other nations at this point in time. So what we do know is that the power sector is increasingly going to need access to location data. We know that this distributed generation that I was speaking about earlier needs a digital approach to network modeling to understand the second order consequences and the complex power flows that result from renewable technology being plugged into the network. We also know that we need a localized understanding of electricity demand. Where is electricity being used? When is it being used? And we know that all of this really needs to work in tandem. So supply and demand need to be predicted in near real time with accurate location data. And this needs to be fed into a digital network graph that can propagate the effects of that through the whole distribution network. And this is really what we've been working on. So the first stage of that is demand prediction. And we have developed in-house a multi-sectoral analytics platform for predicting supply and demand. So we've taken the approach that if we look at lots of different data sets from lots of different sectors, then we can, with a reasonable degree of accuracy, predict demand at that low voltage end of the network to give visibility that at the moment is lacking. So we've combined over 40 million data points from 25 independent data sets that use information from sort of 5 core sectors or 5 core fields: power systems engineering, traffic flow modeling, planning geography, land usage, and socioeconomics. One of the key developments that we've achieved over the course of this MEDApps competition is actually making all of these data sets accessible in under 30 seconds. And you'll see that in a bit when I demo the platform. And that's really a huge development for us. When we started out, it was taking 5 minutes to access all of these data sets. So bringing that down to 30 seconds is a huge development for us. We've also trained some early stage machine learning models to predict local electricity demand at the postcode level to 70% accuracy. And all of that works in tandem with a whole connected digital distribution network that we have developed with the data that are available from our distribution network operators in the UK. So these localized postcode level inputs are combined with what we believe to be a world-first digital distribution network. We have over 500,000 substations now acting as entry nodes, essentially, into a fully connected graph with over 500,000 network links. Early proof of concepts show successful load flow modeling using this digital distribution network, with the capacity in the future to run these network flows in near real time. We are already reaching the limitations of what is possible using the off-the-shelf packages. So one of the key stages of innovation that we're moving on to next is the development of our own in-house load flow modeling that will combine different fields to give accurate load flow analytics. And if you combine all of this together, what you end up with really is a world-first true digital twin with ground-up supply and demand modeling feeding into what is a fully connected digital reconstruction of the distribution network. This digital twin uses location-based approach to predict localized demand and has the capacity in the future to model bidirectional power flows in the electricity network between substations in near real time. Our first go-to-market product that we've developed with this technology is Compass, where we're working with EV charge point developers to perform site optimizations so that they can strategically plan the rollout of rapid and fast EV charging networks. But we're also working now with residential developers for large-scale housing projects, network operators to plan network upgrades, and also renewable and solar developers for strategically finding sites for utility scale solar and wind. I think that's the end of the presentation that I've got, but what I will do is transition quickly over to the other tab, because it's all well and good me sitting here telling you about it. You want to see it. So this, if you sign in to our platform, is the dashboard that you're presented with. You can then go and create a new project. So if we create a new project for EV sites, you can either draw a polygon or select a postcode. For the purposes of this demo, we're going to select a postcode in the central Bristol area. So the postcode area then comes up on screen here. What you then do is enter the minimum demand capacity. So we're saying for a rapid or fast EV charger, you might want 1 megawatt. These draw a lot of power. So maybe you want to draw 1 megawatt. And then you want 15 meters squared, let's say. Now what's going on here is the back end of our platform is in real time doing a minimum viability calculation to select sites within this Bristol area that meet the requirements that you've put in. And you see it's selected here 4 sites. If we zoom in a little bit, you can see these outlines. These are the land registry polygons that exist inside the backend database that you can use to contact landowners if you want to actually develop on their property. If I now go onto the data layers tab, the platform on the back end does a little bit more in-depth analysis using a combination of the data sets that I spoke about earlier. So here we're combining grid data sets and figuring out what the actual capacity is throughout the network. So it's tracking connection availability, not just at the point in the network where you're going to connect, but also tracking it up to the national grid level. It's drawing on data sets, including existing EV charge points, so where exactly might competitors be located. It's also looking at a series of different planning data sets, so flood zones, where are the areas that are high risk of flooding, medium risk of flooding. That's more useful for the utility scale renewable developers. And we're looking at protected areas, protected buildings, so protected areas being a list of about 15 different data sets that you can get from DEFRA that provide you with any restrictions that you might have on planning. There you go, perfect timing. So if I go through this a little bit, you can see the low voltage substations here. So this site 1 can connect to either one of these or these low voltage substations. If I zoom out a little bit, you've got the medium voltage substations over here. So you would connect them at the higher voltage level to this these primary substations. You've got the existing EV charge points that are on the network already, that are on the in the area that you're trying to develop already. If I now zoom in a little and we can overlay the flood zones, so it's pulling the flood zone data sets from back end here, the medium high risk of flooding, as well as areas benefiting from flood defences. So you can see that a lot of the central Bristol area, were it not for flood defences, would be in a floodplain. And if I now look at the protected areas and buildings, so these are all of the listed buildings in the area, as well as any actual kind of parks or polygons that would have restricted development access. We've also got, it's in the beta stage at the moment. So if I zoom in a little bit, this is land use. So this is still a feature that is under development, under active development. But we're overlaying what is the land use of the local area. So it takes those land registry polygons and finds what they're being used for, and then gives you this color-coded output. So you can see here that we've got a lot of residential areas, a few retail areas over here in purple, some offices in blue here. And we've also got transportation links, so all of the major road networks and where you would go to connect to them. So if I now go quickly down through these, so for all of these different data layers, we have tabs. We have more in-depth analysis. So on the substation and the power network capacity tab, we have connection probability at the low voltage end of the network. Because this is a 1 megawatt site, you're not connecting at the low voltage end of the network. That's why the connection probability is 0. But it also tracks headroom capacity up through the network. So you can see here that there is capacity at the medium voltage level, which is for a rapid or fast charger where you would probably connect. But it is constrained at the BSP level above it. And there's demand, there's headroom at the national grid level. So you can track the constraints all the way up through the network. It's not just a case of finding capacity at the point where you want to connect. If I go through quickly now on EV charging utilization, so we draw on data sets from traffic in the local area to estimate what we think that the charging utilization rate is going to be, predicted sort of 5 years into the future. Existing EV chargers are shown on the map. And finally, land use tab, so you could get a breakdown of what the land is being used for in the local area. So it was about 40% residential when I had the overlay on, and that is shown here. And that's just sort of a quick overview of the Farad platform, what we've developed so far. Thank you for listening, and I'll be happy to take any questions. Oh, Fabio, you're on mute.
Yeah, sorry. Great presentation and great demo. We have loads of questions in the chat. I will start from the top. So the first question is, are you using a graph database technology, or what type of database technology are you using?
Yeah, so we're using a mixture of different database technologies. There's obviously some parts of the database that we have, you don't need the power of a graph database. So the locations of EV charge points are just locations. You can just do that with a standard database, but certainly for the network side of it, a lot of our developments we are using graph theory to model network constraints.
All right. The second question, and I will maybe modify it a little bit, saying, do you think that this tool will encourage the kind of planning that we need for long-term net zero? Or do you think that there is the risk that this will simply give the possibility, speed up the process of grabbing the available capacity for the most able to pay?
Yeah, so this is an ethics question, really, isn't it? And it's something that we're sort of continuously iterating on in-house. How do we build ethics and ethical AI into the platform that we're developing? We are aware of that, sort of the potential for it to be used for that. And yeah, we are trying to make sure that it's meritocratic, I guess. Maybe meritocratic is not the right word. We try to make sure that it's used fairly.
May I ask you if you have particular mitigation techniques that you are implementing at the moment in terms of ethics and...
So a lot of it sort of comes from, it's when we're talking to sort of large scale customers and large scale potential clients, it will be a case of, you can't just come to us and ask for like every single site throughout the UK that you could possibly connect to, and then there'll be a huge price tag attached to that if you want to do that with us. So there are sort of some mitigation strategies that we have in place, but it's all ongoing work on our end. It's one of these things where we're breaking into a new market, creating a new market, and yeah, we need to continuously iterate and take on board any kind of scrutiny on that front.
Right. Next question is, well, related to networks, distribution network data. How many low voltage substations does your model have access to? And how did you get access to this data?
So I can say at the moment, we have over 500,000 low voltage substations deployed on the platform. We're looking at getting the rest of the low voltage substations in the UK ingested and deployed by the end of phase 2, so in a couple of weeks' time. How we got access to that data depends on what network operator you're talking about. Basically, Energy System Catapult have helped a lot with that a lot of the time. So there's the new data best practice principles that have been written that basically say all network data needs to be presumed open access, and normally pointing that out helps.
And you said 500,000. In terms of percentage, what do you think is the percentage in terms of coverage that you have? Roughly.
Roughly 70%.
So this is roughly 70% of low voltage substations across UK. Okay, it's impressive, considering the challenges for accessing this data. All right. And next question. Have you looked into aligning with upcoming digital twin standards, such as the Centre for Digital Great Britain Data Management Framework? Are you, looking into that?
Yeah, so we're looking into, absolutely looking into these kinds of data standards. I think so. There was the Ofgem letter that was put out a while ago, can't remember the exact date, talking about moving over to CIM data sets being released by the networks. And essentially everything that we do, everything that we develop in-house, we need to be able to justify it on an academic level. We need to be able to say, well, okay, is this compatible with where we think the data standards are going in 2 years' time, in 5 years' time, in 10 years' time? So we're always looking forward to those digital twin standards and these data standards, trying to make sure that everything we do is compatible with them, even if it's not immediately aligned, because there's a lack of data available. If we sort of decided to just start using one of these digital twin standards, then we wouldn't get 70% of the low voltage substations because the data's not there for it.
Yeah, indeed, this links very well to the next question. Is it possible to ingest network data in a standardized way nowadays? I changed a little bit the question.
Yes, it is. It is possible to do that, and we do have a standardized way of doing it. And I'm not going to say anything more about that.
All right, fair. Can you export information out of this tool? Can a user export information out of the tool?
Yeah, so we've had that from a couple of customers actually. We've had people asking for exporting information. It is something that we are looking into doing. The hesitation on our end for doing that is that our data sets, so because we combine data sets from so many different places, they will get updated on a very regular basis. So you could export some data and download it from our platform, and then it will be out of date very quickly. And whereas if you actually access it directly through the platform, it's always up to date. But absolutely, exporting information is something that we've looked at.
You would be able to download a snapshot of the system.
Yeah, and it would just be a case of saying that this is a snapshot. It might not be accurate in a month's time.
Yeah, we have a question here. Will this be feeding into the ESO's virtual energy system?
Certainly could do. I think it certainly could do. We've not sort of engaged in any discussion on that so far.
Right. A question around use cases and commercialization. So what do you think will be the main type of users for this, and how do you imagine commercializing this tool?
Yeah, so we think at the moment the major users will be developers of low carbon infrastructure. So people that are going to be developing something, some kind of infrastructure that uses a lot of grid capacity, and also the network operators who need to know where to upgrade their network. Those are the kind of two major use cases that we're looking at the moment. And so the commercialization would then be either providing these infrastructure developers with access to the platform so that they can get access to the data sets that they need for the sites that they're looking at developing. And then it will be a monthly software as a service model. Or we can provide direct API access to people. So they could, if someone has an in-house GIS platform, they can just take the outputs of our modeling and feed it directly into their platform.
And when you say infrastructure developers, is there a specific type of technology that you think will be an immediate target? You give a demo on EV charging points, but yeah, do you have some?
Yeah, so we think that the immediate use is the EV charging sector, especially these rapid and fast EV charging networks that are cropping up throughout the UK, because that's quite a large growth sector at the moment. And depending on who you talk to, it doesn't seem as though the locations for these charge points are being particularly strategically chosen. So that's definitely the immediate kind of people that we're targeting at the moment, but we are also aware that that's not a long-term scalable business model, that once the rapid and fast charging networks are up, they are up. And at that point, we're moving over to kind of utility scale, renewable energy, and also low carbon housing and that kind of thing.
And have you looked at local authorities? This brings us to the next question.
Yes, yeah.
Yeah, sorry, go ahead.
Yeah, so absolutely, we've contacted a few different local authorities and ongoing conversations about how we can tailor this to their needs.
And how do you think they could access this tool?
So the way that we're sort of talking with the councils that we're talking with at the moment, the way that we're talking to them about it is, or with them about it is, it would be accessed via a login page. So you would get an account for the platform, and then you would sign in and use it. We kind of, that for us, I think, is long-term way of making the technology scalable, because as we develop the power network modeling more and more, it's going to rely on high performance computing clusters, and that means we need to run it on a cloud-based service. So it would be kind of, log in, see your council area. So that's one of the other data sets actually that we have got in the back end that wasn't shown in the demo. We have all of the council boundaries in the UK, which feeds into the planning. So people who are looking at utility scale renewable development might like to know which councils are more likely to give them planning permission for their project. But also, working with those councils.
And now, a question related to the accuracy of your model and liability that you take for that accuracy. I know that you have mentioned that you use a machine learning algorithm for predicting the demand at postcode level, and you said 70%, if I'm correct, accuracy. So my first question would be, how do you measure that accuracy? And second, what type of liability do you take for that accuracy? And do you have other machine learning, other calculations, or are you on simply displaying data, displaying data layers on your platform?
So in terms of how we kind of validate that accuracy, it's essentially combining all of the data sets that we can find on demand. So this would be demand at the low voltage level, that there are some data sets from WPD that are publicly available, but also demand at the higher voltage level of the network. So one of the technology, so the benefit of the technology that we have is that we can propagate that demand from the low voltage level up through the network. So you can say, okay, if I've got this model that works at the low voltage level, when I propagate the outputs of that upwards, does it align with the upper voltage levels of the network, the data that we have from the upper voltage levels of the network? So it's validating really against these data sets that are publicly available. And as more of those become publicly available, the accuracy will improve. In terms of liability for the accuracy, that's something that enters into commercial discussions. So when we are going through that kind of phase of discussion with customers, there will be a contract written up that states exactly what happens if or when data are not, or the accuracy isn't up to scratch.
So it's going to depend on a case to on the case and
yeah, so it's written into the commercial contract.
Yeah, right. We have a lot of questions here. So the next one is around user interface. What are the digital twin IoT related elements specifically in your tool/application?
So the Internet of Things related elements, well, so the digital twin is essentially, because on the back end, we've got this digital reconstruction of the distribution network that kind of is geographically and topologically accurate. It's a digital twin in the sense that it looks at kind of postcode level granularity and feeds it in from that point. We are looking at kind of going further down in scale, where you would be looking at individual houses and incorporating the Internet of Things side of data there. At the moment, data are not widely available. As far as we can tell, data are not widely available enough to go down to that tiny level of granularity, where you're looking at, Internet of Things, incorporating Internet of Things. It's certainly a plan for the future, but at the moment, the digital twin side of it is kind of higher geographical level, so postcode level and upwards.
Clear. And have you prioritized your, let's say, criteria in terms of thinking about social value and fairness and equitable?
So one of our milestones for phase 2 of this competition is including socioeconomic and demographic data to do precisely that. So that will be 26th of Feb, I think, is the deadline for that. So we're including those data sets precisely so that we can start to think about, those problems.
Right. And there is a question from Steve around open access. So basically, this refers to his previous question. So are you using any open data? Is your part of your platform going to be open access?
So we are using open data, so a combination of a lot of the open data from Icebreaker 1. We've included in the platform. We're also including our own data that we've essentially bought and paid for ourselves. So that would be private data that we've acquired. In terms of making the actual platform itself open access, we don't have any plans for now to do that, but it might come in the future.
And in terms of making any aspect of your, for instance, load flow modeling open source?
Not for now.
Not for now, right. No. Anyway, we have still a lot of questions in the chat and we are running out of time. But what I would say, I will invite you, Andy, and your colleagues to reply to the comments in the chat, because now we need to move to, let's say, the next break and the next presentation. But thank you very much for your presentation. That was great, and for your demo. And yeah, I hope to speak to you soon.
Yeah.
Thank you.
Fab. Thanks.